Swayam Prabha. Digital India. Educated India.
Environmental Impact of Textile Effluent, lecture number 20. Environmental impact of textile effluent is huge. By now we have understood that textile effluents are the main culprit for increasing the pollution load in the ecosystem. Textile effluent, which includes wastewater from textile manufacturing processes, can have significant environmental impact if not properly treated. Here are some of the main environmental concerns associated with textile effluent, and by now all of you must have understood that this is a serious issue. Water pollution. Textile effluent often contains various chemicals, dyes, heavy metals and other pollutants when discharged untreated or inadequately treated into water bodies like river, lakes or oceans. It can contaminate the water and harm the aquatic life. And this we have seen time and again, we have talked about it. This pollution can disrupt ecosystem and reduce biodiversity. Soil contamination. Textile effluent may also find its way into soil through improper disposal practices or runoff. This can contaminate soil, affecting plant growth and agricultural productivity. Additionally, some pollutants in the effluent can leach into the groundwater, further contaminating water sources. So, it is water pollution, it is soil contamination causing all kinds of problems in the ecosystem. Air pollution. Certain volatile organic compounds, that is VOCs, and other chemical present in the textile effluent can evaporate into the air, contributing to air pollution. This pollution can pose health risk to nearby communities and contribute to the formation of smog and other air quality issues. Energy consumption. The treatment of textile effluent requires significant energy inputs, particularly in processes such as biological treatment or advanced oxidation. This can contribute to greenhouse gas emissions and exacerbate the climate change. Microplastics. Textile effluent can contain microplastics, which are tiny plastic particles shed from synthetic fabric during washing. These microplastics can enter water bodies and marine ecosystem, posing risk to aquatic organisms and potentially entering the food chain. We had not spoken so far about microplastics because we were only concentrating on the organic pollutants, the dyes, the PAH, the pesticides, the emulsifiers, the surfactants, heavy metals, but this is another new problem. So, we have to address all these very carefully because all of them have eventually environmental impact. Ecotoxicity. Some chemicals present in textile effluent such as certain dyes and finishing agents can be toxic to aquatic organisms even at low concentrations. This toxicity can lead to fish getting killed, disruption in food chains and long-term ecological damage. Addressing the environmental impact of textile effluent requires a combination of regulatory measures, technological advancements in wastewater treatment, adoption of cleaner production processes, and industry-wide initiatives to promote sustainability and responsible waste management practices. Environmental impact by textile effluent on water pollution. Let us now look one by one. We saw it causes water pollution, we saw it causes soil contamination, we saw it causes air pollution, it causes pollution created by the microplastics and energy consumption, of course. So, textile effluent is a significant contributor to water pollution due to a variety of chemical and pollutants it contains. Here is how textile effluent impact water pollution, and we have seen this time and again. In many of the lectures in the past, we have emphasized about the water pollution. Chemical contamination. Textile effluent contain various chemicals, a variety of chemicals used in dyeing, finishing, printing and other manufacturing processes like sizing, desizing, curing, mercerizing, singeing and so on. These can include heavy metals such as chromium, lead, cadmium as well as toxic organic compounds like formaldehyde, phthalate and chlorinated solvents. When discharged into the water bodies without proper treatment, these chemicals can contaminate the water and pose risk to aquatic life and also to human life. Dye contamination. Dyes used in the textile processing or production can be particularly problematic as they can persist in water even after dilution. Many textile dyes are non-biodegradable and can have adverse effect on aquatic ecosystems such as reducing light penetration and disrupting photosynthesis, which impacts aquatic plant and algae growth. Additionally, some dyes may be toxic to aquatic organisms, leading to reduced biodiversity and ecological imbalances. So, it can be as serious as that. pH imbalances. Textile effluent can also alter the pH levels of water bodies. Certain textile processing chemicals such as alkalis and acids used in the dyeing and finishing can increase or decrease the pH of water, leading to acidity or alkalinity. Fluctuations in pH can disrupt aquatic habitats and impair the ability of aquatic organisms to survive and reproduce. Nutrient imbalance. Textile effluent may contain nutrients such as nitrogen and phosphorus, which can promote eutrophication when discharged into water bodies. Eutrophication occurs when excessive nutrients stimulate algal growth, leading to algal blooms. These blooms can deplete oxygen levels in the water, causing fishes to get killed and harming other aquatic organisms. Sedimentation. Textile effluent may carry suspended solids and sediments which can cloud the water and impair light penetration, causing turbidity. This can affect the growth of aquatic plants and benthic organisms as well as disrupt sediment dwelling species. Excessive sedimentation can also smoother habitats such as coral reefs and aquatic spawning grounds. To mitigate the water pollution caused by textile effluent, it is crucial to implement effective wastewater treatment technologies. So, one thing is sure that because the pollution problem increases so much because of the untreated wastewater being discharged into the water bodies, one has to take very serious measures enforcing Regulatory standards for pollutant discharge promote the use of eco-friendly dyes and chemicals in textile production and encourage the adoption of water recycling and reuse practices within the textile industry. Additionally, public awareness and education about the environmental impacts of textile pollution can help drive consumers' demand for sustainable and responsibly produced textile. And as I told you in one of the lectures, that even the consumer has become very aware, and they know if the product is made sustainably, they promote and buy those kind of products because they are sure that the end result of this production has been looked into very seriously and there are no adverse environmental impacts. Textile effluent can contribute to soil contamination through various pathways, primarily through improper disposal practices, runoff, and land applications of untreated wastewater. Here are some ways textile effluent impacts soil contamination. So, how does it? We saw water contamination, water pollution. Now, let us look into soil pollution or soil contamination. Chemical contaminants. The textile effluent contains a wide range of chemicals used in the manufacturing process, including dyes, finishing agents, solvents, and heavy metals. When textile effluent is disposed of on the land or when runoff carries it into the soil, these chemicals can get accumulated in the soil over time, leading to contamination. Some of these chemicals may persist in the soil for extended period, posing risk of soil quality and affecting plant growth. Heavy metals. Many textile dyes and processing chemicals contain heavy metals such as chromium, lead, cadmium. These metals can leach into the soil, especially in areas where textile effluent is directly disposed of or where wastewater treatment systems are inadequate. Heavy metal contamination in soil can have detrimental effects on soil health, inhibit microbial activity, and negatively impact plant growth. Furthermore, heavy metals can bioaccumulate in plants, posing risk to human health if contaminated crops are consumed. So, there is a great danger that if the heavy metals are contaminating the soil, then the produce that agricultural produce that is formed on that land can bioaccumulate these heavy metals and it can go into the human food chain. pH imbalance. Textile effluent may alter the pH of the soil, particularly if it contains acidic or alkaline substances used in dyeing and finishing processes. Fluctuation in soil pH can affect nutrient availability, microbial activity, and overall soil fertility. Soil pH extremes can also impact plant growth and alter the composition of soil microbial communities, leading to ecological imbalances. Salinity. Textile effluent may contain salts and other dissolved solids which can accumulate in soil over time, leading to salinity problems. Excessive salinity can affect soil structure, reduce water infiltration and drainage, and inhibit plant growth. Salinity stress can also increase the susceptibility of plants to pests and diseases, further impacting agricultural productivity. So, there are many problems if there is salinity in the soil, and we have seen this, that some of the runoffs of the textile industrial water, when they are put and have large amount of salt which are used as leveling agents, not only sodium chloride but Glauber salt. These can create the agricultural land to turn into a barren land. So, this affects the productivity definitely. Then comes the problem of microplastics. Textile effluent may contain microplastics, which are tiny plastic particles shed from synthetic fabrics during washing. When the textile effluent is applied to land or when runoff carries it into soil, microplastics can accumulate even in the soil. Microplastics in soil can affect soil biota, disrupt soil ecosystem and potentially enter the food chain through soil dwelling organisms. To mitigate soil contamination by textile effluent, it is essential to implement proper wastewater treatment measures to remove harmful pollutants before discharge. Additionally, regulations and guidelines should be enforced to ensure responsible disposal practices within the industry, including safe handling and treatment of wastewater in the textile industry. Soil remediation techniques may also be necessary in areas already affected by textile effluent contamination. Then how does it affect the environmental impact of textile effluent on air pollution? So far we saw water pollution, soil contamination. Now let us look at how does it impact the air pollution. Textile effluent can contribute to air pollution through various mechanisms, primarily involving the release of volatile organic compound, that is VOCs, particulate matter and greenhouse gases. Here is how textile effluent impacts air pollution. Volatile organic compounds, the VOCs. Many chemicals used in textile manufacturing such as solvents, dyes and finishing agents contain VOCs. During various stages of textile production, including dyeing, printing, finishing, VOCs can evaporate into the air, and this we cannot see with our naked eyes. At least the dyes we can see in the watercolor, but these are invisible. Once released, VOCs can react with other air pollutants and can with sunlight to form secondary pollutants such as ground level ozone, smog, and which can contribute to air pollution and can have adverse effect on human health due to inhalation of this smog. Particulate matter, PM. Textile manufacturing processes, particularly those involving mechanical treatments like spinning, weaving, cutting, can generate particulate matter. These fine particles can become airborne and contribute to air pollution, especially in indoor environments where ventilation may be limited. Inhalation of particulate matter can lead to respiratory problems and exacerbate existing health conditions such as asthma and cardiovascular disease. Odor. Some chemicals used in textile production, particularly those in dyeing and finishing processes, can produce unpleasant odor. These odors can be released into the air from textile manufacturing facilities and may impact air quality in surrounding areas. While odor themselves may not be harmful at low concentration, they can cause nuisance and discomfort to nearby residents. And we have seen that sometimes some gas leakage is there and that is a very foul smell. Greenhouse gas emission. The treatment of textile effluent often requires energy intensive processes such as biological treatment, chemical oxidation and wastewater aeration. The energy used in these processes can lead to the emission of greenhouse gases such as carbon dioxide and methane, contributing to climate change and global warming. Additionally, some textile manufacturing processes such as polyester production directly emit greenhouse gases during the production of the synthetic fibers. So, these gases which are carbon dioxide and methane can also be extremely harmful and can be an addition in the air pollution. Indoor air quality. In addition to outdoor air pollution, textile manufacturing can also impact indoor air quality in production facilities and surrounding areas. Poor ventilation combined with release of VOCs, particulate matter and odorous compound can create unhealthy indoor air conditions for workers and nearby residents. To mitigate the air pollution caused by textile effluent, it is essential for textile manufacturers to implement pollution prevention measures, adopt cleaner production technologies and improve wastewater treatment processes to minimize the release of harmful pollutants into the air. Additionally, regulatory standards of air emission should be enforced to limit the environmental impact of textile manufacturing activities. Now, rules have been laid down for all these emissions, but it is for the textile manufacturing units to follow them. How does energy consumption help or impact the environmental situation? The energy that is consumed for textile effluent. Textile effluent indirectly contribute to energy consumption primarily through the treatment processes required to mitigate its environmental impact. Here is how textile effluent impacts energy consumption. Wastewater treatment. Now, every process would require energy. So, wastewater treatment, one of the primary ways of textile effluent affects energy consumption is through the energy intensive processes involved in wastewater treatment. Treating textile effluent to remove pollutants and contaminants typically requires various treatment methods such as physical, chemical and biological processes, and this we have learnt earlier. These treatment processes such as aeration, filtration, chemical oxidation often require significant amount of electricity to operate pumps, mixers, blowers and other equipment. The energy demand for wastewater treatment can be substantial, especially in large scale textile manufacturing facilities or in regions with strict environmental regulation. Heat energy. Some wastewater treatment processes, particularly those involving thermal treatment or evaporation, require heat energy to achieve effective treatment outcomes. Heating wastewater to high temperatures for disinfection or thermal evaporation of water content consume additional energy, contributing to overall energy consumption being high associated with textile effluent treatment. So, we know that at every stage energy is being used, or for evaporation heat is being used, which is indirectly coming from energy. So, it is quite intensive in the processes. Transportation also requires energy consumption. Energy is also consumed in transporting textile effluent from manufacturing facilities to wastewater treatment plants if they are not located in the same premises, or to transport sludge. Depending on the distance and transportation mode used, trucks or pipelines, energy may be expended in pumping, trucking and other transportation activities. Resource extraction and processing. The production of chemicals, materials and equipment used in wastewater treatment processes also require energy. For example, the production of chemicals used for coagulation, flocculation and pH adjustment in wastewater treatment involves energy intensive processes such as chemical synthesis and purification. Water recycling and reuse. In some cases, textile manufacturers may invest in water recycling and reuse system to minimize freshwater consumption and less of wastewater generation. While water recycling can reduce the environmental impact of textile effluent, the implementation and operations of these systems may require additional energy inputs for water treatment, filtration and distribution. To minimize the energy consumption associated with textile effluent, manufacturers can implement energy efficient technologies and practices in wastewater treatment processes. This may include optimizing treatment plant design, using energy efficient equipment, implementing process controls to minimize energy use and exploring renewable energy resources such as solar or biogas for on-site energy generation. Additionally, promoting water conservation measures and reducing the generation of textile effluent through cleaner production methods can also help minimize the energy footprints of textile manufacturing operations. Textile effluent contribute to microplastic pollution, this we have just learned, which has become a significant environmental concern globally, because this is a newly acquired and newly found contaminant which is having an adverse effect on the environment. Microplastics are tiny plastic particles measuring less than 5 millimeter in size, and they can originate from various sources including the breakdown of larger plastic items, abrasion of synthetic textile and the discharge of microbeads from personal care products. Here is how textile effluent impacts microplastic pollution. Synthetic fiber shedding. Synthetic fiber such as polyester, nylon and acrylic are commonly used in textile manufacturing. When textiles made from these synthetic fibers are washed or during production processes like cutting and sewing, they shed microplastic fibers. These microplastic fibers are released into the wastewater and can end up in textile effluent. Wastewater discharge. Textile effluent which contains microplastic fibers shed from synthetic textile is discharged into wastewater, treatment plants or directly into water bodies. However, conventional wastewater treatment processes are not designed to effectively remove microplastic from effluent, leading to the release of microplastic in the environment. As I told just a while ago, that microplastics have been identified as one of the major pollutants recently which is impacting the environment. The conventional methods have not been designed to remove them. Aquatic contamination. Once released into the water bodies, microplastics from textile effluent can accumulate in aquatic environments, including river, lakes and oceans. These microplastics can persist in the environment for long periods, posing risk to aquatic organisms such as fish, crustaceans and aquatic birds. Microplastics can be ingested by marine life, leading to physical harm, internal blockages and potential transfer of toxic chemicals associated with the plastic particles. So, they can be very serious impact of the microplastic. Bioaccumulation. Microplastics can bioaccumulate in the food chain, starting from small aquatic organisms and eventually reaching larger predators including humans. This bioaccumulation process can lead to the magnification of microplastic concentrations and associated contaminants in organisms at high trophic levels, posing risk to ecosystem health and human health. Ecological impact. Microplastic pollution from textile effluent can have detrimental ecological impact. This we have understood very clearly by now, including disruption to marine ecosystem, alteration of food webs and habitat degradation. Additionally, microplastics can serve as vectors for harmful microorganisms and pollutants, further exacerbating environmental risk. To address the environmental impact of microplastics from textile effluent, efforts are needed at various stages and levels, including developing and implementing wastewater treatment technologies specifically designed to capture and remove microplastics from the effluent. There is a need for development of such methods and technologies, promoting the use of sustainable and biodegradable alternative to synthetic fibers in textile production, raising awareness among consumers, textile manufacturers and policy makers about the environmental consequences of microplastic pollution and the importance of mitigating its impact. Implementing regulation and policies to minimize the release of microplastics into the environment and encourage responsible waste management practices. Supporting research, innovation to develop more effective methods for monitoring, detecting and mitigating microplastic pollution in aquatic environment. Now, let us move on to ecotoxicity. What is the environmental impact of textile effluent? A textile effluent can have significant ecotoxicological impact due to the presence of various chemicals and pollutants that are toxic to aquatic organisms and ecosystem. Here is how textile effluent contributes to ecotoxicity. Chemical contaminants. Textile effluent contain a wide range of chemicals used in textile manufacturing processes, including dyes, finishing agents, solvents and heavy metals. Many of these chemicals are toxic to aquatic organisms even at low concentration. When textile effluent is discharged into water bodies without proper treatment, these chemicals can accumulate and pose risk to aquatic life, including fish, invertebrates and algae. Acute and chronic toxicity. Some chemicals present in textile effluent can cause acute toxicity, including leading to immediate harm or death of aquatic organisms upon exposure. They can be so toxic and chronic. Others may cause chronic toxicity resulting in long-term adverse effect such as reproductive impairment, developmental abnormalities and reduced growth and survival rates. These toxic effects can disrupt aquatic ecosystem and lead to declines in biodiversity. So, it can be very, very serious because they can be very toxic and they can disrupt the whole ecosystem and reduce the biodiversity. Bioaccumulation. Certain chemicals found in textile effluent such as persistent organic pollutants POPs and heavy metals have the potential to bioaccumulate in the tissues of aquatic organisms. Bioaccumulation occurs when organisms absorb chemical from the surrounding environment faster than they can eliminate them. As predators consume contaminated prey, the concentration of the toxic chemical can increase up the food chain, posing risk to higher trophic levels including humans. So, it can reach slowly from one aquatic animal. If the fish is consumed by the human being, then it reaches the system, then it bioaccumulates in the system. Endocrine disruptor. Some chemicals present in textile effluents such as certain dyes and surfactants have been identified as endocrine disrupting compounds EDCs. These chemicals can interfere with the endocrine system of an aquatic organism, disrupting hormonal balance and reproductive function. Endocrine disruption can lead to impaired fertility, feminization or masculinization of individuals, and population level effect such as reduced reproductive success and altered sex ratios. Habitat degradation. Textile effluent can contribute to habitat degradation in aquatic ecosystem by altering water quality parameters such as pH, dissolved oxygen level and nutrient concentrations. Changes in water quality can impact the distribution and abundance of aquatic species, disrupt ecological processes and lead to shifts in community structure. So, even some of the species can just become obsolete because of this seriousness of ecotoxicity. To mitigate the ecotoxicological impact of textile effluent, it is essential to implement effective wastewater treatment technologies to remove harmful chemicals and pollutants from discharge. Time and again we are talking about this, that it is a serious problem. It needs to be handled very carefully and understood very well. Additionally, regulations and enforcement measures should be in place to limit the release of toxic substances into the environment and promote the use of safer alternatives in textile manufacturing processes. Monitoring programs can help assess the ecological health of aquatic ecosystem and identify areas where remediation efforts are needed to mitigate the impact of textile effluent on aquatic organisms and ecosystem. Technological advancement in wastewater treatment to prevent environmental impact. We have studied that all these measures that are being, new technologies that are being introduced are primarily to reduce the contaminants or pollutants. So, technological advancement in wastewater treatment have been instrumental in mitigating the environmental impact, and that is the focus to deal with textile effluent. Here are some key innovations and advancement in wastewater treatment technologies aimed at addressing the environmental challenges posed by the textile effluent. So, now let us look from the environmental impact point of view. What are the technologies which are most effective? Advanced oxidation processes, AOPs. AOPs utilize powerful oxidants such as ozone, hydrogen peroxide or ultraviolet light to degrade organic pollutants and colorants present in textile effluent. These processes can efficiently break down complex organic compounds and dyes into simpler, less harmful substances, reducing the environmental impact of effluent discharge. Membrane filtration. Membrane filtration technologies including reverse osmosis, nanofiltration, ultrafiltration are increasingly being used to remove suspended solids, dissolved contaminants and microorganisms from the textile effluent. Membrane filtration offers high removal efficiency and can produce high quality effluent suitable for reuse or discharge into sensitive environments. Biological treatment. We have studied all this, but we are now looking from the environmental impact point of view. Biological treatment method such as activated sludge, sequencing batch reactors, SBRs and constructed wetland harness the metabolic activity of microorganisms to degrade organic pollutants in textile effluent. Advances in biological treatment include the use of specialized microbial consortia, biofilm reactors and optimization of process conditions to enhance treatment performance and reduce treatment times. Adsorption technologies. Adsorption processes such as activated carbon adsorption and ion exchange can effectively remove organic contaminants, colorants and heavy metals from textile effluent. Advances in adsorbent material, surface modification techniques and regeneration methods have improved the efficiency and cost effectiveness of adsorption based treatment systems. Advanced chemical precipitation. Chemical precipitation methods such as coagulation, flocculation, which we have studied many times, we are now looking from the point of view of environmental impact reduction, are commonly used to remove suspended solids, colloidal particles and certain organic pollutants from textile effluent. So, recent advancements in chemical precipitation include the development of novel coagulants, optimization of dosing strategies and integration with other treatment processes to enhance pollutant removal efficiency. So, the aim of advanced chemical precipitation is somehow to remove the pollutants more efficiently. Electrochemical treatment. Electrochemical technologies such as electrocoagulation, electrooxidation, electrochemical advanced oxidation processes, that is EAOPs, utilize electric current to facilitate the removal and degradation of contaminants in textile effluent. Electrochemical treatment offers advantages such as selective pollutant removal, minimal sludge generation and potential for on-site treatment applications. Green and sustainable technologies. There is growing interest in the development of green and sustainable wastewater treatment technologies for textile effluent in the current times. World over, people are working, and globally it is of major concern that greener and sustainable technologies should be brought in. So, these would include phycoremediation using microalgae, phytoremediation using aquatic plants and biochar assisted treatment processes. These nature based approaches offer environmentally friendly solution for pollutant removal and nutrient recovery from textile effluent. Overall, continued research and development efforts in wastewater treatment technologies, coupled with implement of best management practices and regulatory measures, are essential for minimizing the environmental impact of textile effluent and ensuring sustainable water management practices in textile industry. Adoption of cleaner production processes for minimizing environmental impact due to textile effluent. So, there is a need to adopt cleaner production processes in textile industry, and it is crucial for minimizing the environmental impact of textile effluent. Cleaner production focuses on reducing resource consumption, waste generation and environmental pollution throughout the entire life cycle of the textile product. Here are some strategies and practices for implementing clean production processes to mitigate environmental impact and textile effluent. Pollution prevention. First and the foremost thing is that how can we prevent the generation of pollution? Implementing pollution prevention measures at the source to minimize the generation of pollutants and waste during the textile manufacturing processes. This includes optimizing production processes using alternative materials and chemicals and adopting closed loop system to minimize resource consumption and waste generation. Water consumption and recycling. Implementing water conservation measures to reduce water consumption and wastewater generation in textile production. This includes optimizing water use efficiency, recycling and reusing process water and implementing water saving technologies such as low water dyeing or waterless printing techniques. Chemical management. We have spoken about chemical management, that if we use less of chemicals in the chemical processing, only the optimal amount, then less will be disposed of in the effluent. Adopting safer and more environmentally friendly chemicals and dyes in textile production to minimize the release of hazardous substances into the environment. This includes using eco-friendly dyes and finishing agents, substituting toxic chemicals with less harmful alternatives, and implementing chemical management system to track and reduce chemical use wherever possible. Energy efficiency. Improving energy efficiency in textile manufacturing processes to reduce energy consumption and greenhouse emissions. This includes investing in energy efficient equipment and machinery, optimizing process conditions to minimize energy use, and utilizing renewable energy resources such as solar and wind power and not depending on fossil fuels. Waste reduction and recycling. Implementing waste reduction and recycling initiatives to minimize solid waste generation and maximize resource recovery. We have been all along talking about resource recovery. Now, that is because whatever we can extract which can be useful from the waste that is generated after textile processing, we should do that. This includes segregating and recycling textile waste, composting organic waste, and converting waste material into valuable byproducts or inputs for other industries. Supply chain collaboration. Collaborating with suppliers, manufacturers, stakeholders across the textile supply chain to promote sustainability and responsible production practices. This includes engaging suppliers to adopt cleaner production methods, sourcing materials from environmentally certified suppliers, and promoting transparency and accountability throughout the supply chain. So, it is not just the responsibility of the textile manufacturer, it is the entire supply chain should be such that everybody feels responsible for reducing the environmental impact. Life cycle assessment. Conducting life cycle assessment, that is LCAs, to evaluate the environmental impact of textile products from raw material extraction to end of life disposal. LCAs can help identify hotspots in the production process and inform decision making to minimize environmental impacts and improve sustainability performances. Continuous improvement. There is a need for continuous improvement. Establishing a culture of continuous improvement and innovation to drive ongoing advances in cleaner production practices. Now, more and more people are driving towards cleaner technologies, and there are lot of research happening all over the world where people are focusing for effluent treatment and developing cleaner and cleaner technologies. This includes setting environmental performance target, monitoring key performance indicators, and regularly reviewing and updating production processes to incorporate new technologies and best practices. Adopting cleaner processes, the textile industry can reduce its environmental footprint, minimize the generation of textile effluent, and contribute to more sustainable and responsible practices in textile manufacturing. So, there is a need for continuous improvement because new compounds are coming into knowledge which are impacting the environment, and therefore, newer technologies, cleaner technologies have to be devised and practiced. So, to summarize, in conclusion, the environmental impact of textile effluent is significant and multifaceted, encompassing water pollution, soil contamination, air pollution, microplastic pollution, ecotoxicity, and energy consumption. Textile effluent contains a diverse array of pollutants including chemicals, dyes, heavy metals, microplastics, surfactants, emulsifiers, and so on, which can pose risk to aquatic ecosystems, soil quality, air quality, and human health. These pollutants can have acute and chronic effect on aquatic organisms, disrupt ecological processes, and degrade natural habitats. Addressing the environmental impact of textile effluents requires a holistic approach that encompasses regulatory measures, technological advancements, cleaner production practices, and stakeholders' collaboration. So, it is not just one person's effort. All the people in the supply chain are responsible, and environmental impact is a collaborative responsibility, which requires that regulatory measures should be in place, technological advancements should be in place, cleaner production practices, and all of that should be implemented together. So, to conclude, efforts to mitigate the environmental impact of textile effluent should focus on implementing effective wastewater treatment technologies to remove pollutants, promoting the adoption of cleaner production processes to minimize resource consumption and waste generation, and fostering sustainability throughout the textile supply chain. Because we have to feel responsible that textiles will be formed, garments will be made as long as human beings are on this planet. But we have to keep the planet safe from all these chemical pollutants, and for that it is necessary to work on it in a very concerted manner. Furthermore, raising awareness among consumer industry, stakeholders and policy makers about the environmental consequences of textile effluent and the importance of sustainable textile production practices is essential for driving positive change. It cannot happen just by one person's effort. It is a collaborative effort that everybody has to feel that environmental impact has to be reduced generated from textile effluent. So, how can we do that? The processes have to be optimized. The chemical management system should be in place. As far as possible, recovery of the resource should be done. Energy should be used less. There should not be any major water pollution caused by the textile effluent, so the treatment plants should be well effective. The technologies that have been started should be very, very effective and cost effective as well. So, in order to do that, by textile production practices, it is possible to have a positive change if we adapt new technologies. By prioritizing environmental sustainability, innovation and continuous improvement, the textile industry can minimize its environmental footprint and contribute to the protection and preservation of natural resources for future generation. And if you recall, we had done a chapter on sustainable and green approach. So, now is the time that we have to all work towards those approaches, make technological advancements in a manner which will reduce the water consumption, and so more emphasis is now laid on waterless dyeing or printing processes which would require less water. Dyeing should be done where the water can be recycled and reused in the own system. So, that is the kind of approach that is required at the current time. So, with this we have come to an end of this lecture, and what we have learned, the takeaway from this lecture is that somehow we have to reduce the environmental impact very consciously. Looking at the air pollution point of view, looking at the water pollution point of view, the soil contamination point of view, we have to all think that this is going to be a serious matter, and if we do not take proper measures now, it will be too late and the planet will not be fit for living. Hence, each one of us have to feel responsible. So, with this we have come to an end of this lecture, and so we will understand that the environmental impact is very important. And we have to look at the textile effluent not as an enemy, but as a friend. How can we help this textile effluent to not contaminate the water bodies or the air quality or the soil, on how to mitigate and look for solution for microplastics. So, this is the need of the hour, and with this we now stop and end this lecture. Thank you.